Hello. If you're here, you're probably winding down for the evening, or perhaps you've set aside this time to escape into something a little different. Whatever brought you here, I want you to know that what follows isn't designed to startle or agitate. Instead, this is an invitation to forget about time for a while, to let go of the clock, the notifications, and the endless stream of daily concerns. I'm going to walk you through 50 things about your own body, the very vessel that carries you through every moment of your life that you very likely have never heard before. Some will be strange. Some will reframe how you think about yourself entirely. Others might seem insignificant until you realize their extraordinary implications. So settle in, get comfortable, and let's begin to see what we've been living in all along without truly knowing it. 1. Your body contains about 37 trillion cells, but you're constantly replacing them. Right now, as you're listening to this, your body is in a state of perpetual renovation. Every single second of every single day, your cells are aging, dying, and being replaced by new ones. You're not the same person physically that you were 7 years ago. In fact, most of the cells that make up your body at this very moment didn't exist a decade back. The exceptions are interesting. Your brain cells, your heart cells, and the cells in the lens of your eyes tend to stick around for your entire life, which makes them rather precious in the grand scheme of things. But nearly everything else, your skin, your hair, your bones, your blood, is being swapped out continuously. It's like living in a house where the walls are being repainted while you're still inside. You're essentially a walking renovation project that never quite finishes, always in the process of becoming yourself. 2. You shed about 30,000 skin cells every single minute. That dust you see floating in a sunbeam, a substantial portion of that is you. Right now, about 30,000 skin cells are falling off your body every 60 seconds. That's roughly 1.8 million cells per hour. In a single day, you shed about 1.5 pounds of skin. Over the course of a year, you're losing about 600 pounds of skin cells, though your body weighs nowhere near that. Your body replaces your entire outer layer of skin roughly every 2 to 4 weeks. The dust in your home, the debris under your bed, the grime that collects on surfaces you touch frequently, a significant amount of that is simply you, shed and scattered. It's a humbling realization that we're always leaving bits of ourselves everywhere, quite literally dispersing ourselves throughout our environment without even noticing. 3. Your skin weighs about 8 pounds and covers almost 22 square feet. If you were to peel your skin off and lay it flat, it would cover an area roughly equivalent to the size of a large yoga mat or a decent portion of a bedroom wall. That's a tremendous expanse of tissue, and it serves as your body's primary defense system against the outside world. Your skin isn't a simple membrane. It's composed of multiple layers, each with distinct functions. The outer layer, the epidermis, is where most of that shedding we just discussed occurs. Beneath that is the dermis, which contains your hair follicles, sweat glands, and nerve endings that allow you to feel the world around you. And beneath that is the hypodermis, which contains fat that insulates your body and provides cushioning. All of this makes up something that weighs about 8 pounds on an average adult. It's one of your largest organs, and it's so familiar to you that you rarely think about it at all. 4. Your body is about 60% water, but this percentage changes depending on age and gender. A newborn baby is approximately 75% water. An adult man is typically around 60% water. An adult woman is usually closer to 55% water. An elderly person might be as low as 50% water. As we age, we gradually dry out, which is one reason why elderly individuals are more susceptible to dehydration and need to be more mindful about their fluid intake. That water is distributed throughout your body in very specific ways. Some of it is inside your cells, some of it is in the spaces between your cells, some of it's in your blood. Your brain is about 73% water. Your lungs are approximately 83% water. Your skin is around 64% water. Even your bones, which seem like they should be relatively dry, are about 31% water. You are, in a very literal sense, mostly composed of the same substance that fills oceans and falls from the sky. You're a walking collection of water that happens to have developed consciousness. 5. You have about 96,000 miles of blood vessels in your body. If you were to take every artery, vein, and capillary in your body and lay them end to end, they would stretch around the Earth almost 4 times, nearly 100,000 miles. The majority of these are capillaries, which are so thin that red blood cells can barely fit through them. In some places, they're only about 5 micrometers in diameter. If you could see them all at once, your body would appear as an impossibly complex web of pathways, every bit as intricate as a city's entire infrastructure. These vessels are constantly working, delivering oxygen and nutrients to every cell and collecting waste products. They're doing this right now, and they'll keep doing it until your heart stops beating. Most of the time, you're completely unaware of this vast network moving blood through your body with relentless, automatic precision. It's one of the greatest underappreciated systems you possess. 6. Your heart beats about 100,000 times per day. Your heart will beat roughly 100,000 times today. That's about 3 billion beats in an average lifetime. Most people never really think about this. Your heart is beating as you read this, as you sleep, as you work, as you exercise. It never takes a break. It never gets a vacation. It's been beating continuously since before you were born, when you were just a collection of cells in your mother's womb. The sound of your heartbeat, that thump-thump you hear when you place your hand on your chest, is actually the sound of your heart's valves snapping shut. It's a physical mechanism that prevents blood from flowing backward. Every beat serves a purpose, moving blood through your body and keeping you alive. It's such a fundamental part of existence that we rarely acknowledge just how remarkable it is that this organ never stops, never falters, never needs to be consciously controlled. Your heart is perhaps the most dependable part of you. 7. You produce about 25,000 quarts of saliva in your lifetime. This is one of those facts that sounds absurdly high until you do the math. You produce about 1 to 1.5 liters of saliva every single day. Over 70 or 80 years, that adds up to approximately 25,000 quarts, or about 6,250 gallons. That's enough to fill an average swimming pool. Saliva isn't just for keeping your mouth wet. It contains enzymes that begin the process of breaking down food. It contains antibodies that help fight off infections. It helps you taste food by dissolving molecules so your taste buds can detect them. It's constantly being produced, whether you're eating or not, whether you're awake or asleep. When you're sleeping, you produce less saliva, which is partly why your mouth feels drier when you first wake up. Saliva is one of those things that's so mundane and automatic that we think about it only when something's wrong, when our mouths are too dry or when we're dealing with some kind of salivary gland issue, but it's actually a sophisticated chemical solution that your body is manufacturing continuously. 8. Your brain uses about 20% of your body's energy. Despite being only about 2% of your body's weight, your brain is an extraordinary energy consumer. It weighs about 3 pounds, which is roughly 2% of an average adult's body weight, yet it accounts for approximately 20% of your body's total energy consumption. This is why you feel mentally fatigued after intense cognitive work. Your brain isn't just running on air, it's burning through glucose at a tremendous rate, especially during periods of concentration or learning. This is also why people with certain neurological conditions or who engage in high-level intellectual work tend to need more food. Your brain doesn't store much glucose, which means it needs a constant supply. If your blood glucose drops too low, your brain is one of the first things that suffers. This is partly why you might feel foggy or irritable when you're hungry. Your brain is constantly working, even when you're resting. During sleep, your brain is still consuming about 20% of your body's energy, sorting through memories, consolidating learning, and performing maintenance on itself. 9. You have a specialized system in your ears that detects motion, not just sound. Your ears do more than process sound. Inside your inner ear, there's a system called the vestibular system that detects motion and balance. It's composed of 3 semicircular canals that are oriented in different directions. When you move your head, fluid inside these canals sloshes around, and specialized cells detect the movement. This is how you know whether you're moving up or down, forward or backward, or spinning. This is also why motion sickness happens. When what your eyes are telling you doesn't match what your vestibular system is detecting, it creates a conflict that makes you feel nauseous. If you've ever felt dizzy after spinning around, that's your vestibular system and your visual system sending conflicting messages to your brain. People who suffer damage to their vestibular system can lose their sense of balance entirely and struggle with basic tasks like walking in a straight line. The vestibular system is so fundamental to our perception of where we are in space that we take it completely for granted until something goes wrong. 10. Your eyes contain about 130 million light-sensitive cells. Your retina, which is the light-sensitive tissue at the back of your eye, contains approximately 130 million photoreceptor cells. These are divided into 2 types, rods and cones. The rods are sensitive to light and dark and are the cells you rely on for night vision. The cones are sensitive to color and fine detail and require more light to function. You have roughly 120 million rods and about 7 million cones. This is why your color vision is worst in dim light. Your rods take over when it's dark, but they don't detect color. This is also why you see the world in shades of gray when you're in very low light conditions. These 130 million cells are all working together to convert light photons into electrical signals that your brain can interpret. The processing is so sophisticated and happens so quickly that you're not aware it's happening at all. You simply see. You experience the world as a seamless visual field. But what's actually happening is an incredibly complex conversion of light into neural signals. 11. Your eyes move involuntarily about 100,000 times per day. Your eyes are never still. Even when you're looking directly at something, your eyes are constantly making tiny, jerky movements called saccades. These happen so quickly and so automatically that you're not aware of them. They occur about 100,000 times per day. These tiny movements serve a purpose. They prevent your vision from fading. If your eyes were to stay completely still, the image on your retina would become static, and you'd actually become blind to stationary objects. Your visual system relies on movement and change to perceive the world. This is why if you try to keep your eyes absolutely still and look at a fixed point, the world will start to blur and fade. Your brain uses these constant micro movements to maintain your perception of the world. Additionally, your eyes are constantly making larger movements as you scan your environment, follow moving objects, and shift your attention from one thing to another. Over the course of a single day, your eyes perform an incredible amount of work, and you're not conscious of most of it. 12. You lose about 100 head hairs every single day, but you'll never go completely bald unless something's wrong. Every hair on your head has a lifespan. It grows, stays in place for a while, and then falls out. New hairs grow to replace it. On average, you lose about 100 head hairs every day. This is completely normal and happens to everyone. If you find 100 hairs in your shower, don't panic. That's not excessive. That's exactly what's supposed to happen. The hairs are in constant rotation. Each follicle cycles through a growth phase, a transition phase, and a resting phase before the hair falls out and the cycle begins again. For head hair, this cycle takes several years. A single strand of head hair can stick around for anywhere from 2 to 7 years before it's shed. This is why you can grow your hair quite long if you want to. With this extended growth cycle, most of your hair follicles aren't reaching the shedding phase at any given time. If you suddenly start losing significantly more than 100 hairs per day, that's when it's worth investigating. This could indicate stress, nutritional deficiency, hormonal changes, or an underlying medical condition. But the baseline loss of 100 hairs daily is just your body's normal maintenance routine. 13. Your nose can detect certain smells in concentrations as low as 0.5 parts per trillion. Your sense of smell is far more sensitive than most people realize. Your nose contains millions of olfactory receptors, specialized cells that detect odor molecules. Some people can smell certain compounds at concentrations as low as 0.5 parts per trillion. This is so sensitive that if you were to put one drop of a particular odor in an Olympic-sized swimming pool, you would be able to smell it. To put this in perspective, this is vastly more sensitive than most of our technological devices can detect certain compounds. You have about 400 types of smell receptors, and your brain can distinguish between thousands of different odors. The sense of smell is also intimately connected to memory and emotion. When you smell something, the signal goes directly to parts of your brain involved in memory and emotion before it reaches the part of your brain responsible for conscious thought. This is why a particular smell can instantly transport you back to a childhood memory or evoke a strong emotional response. Smells bypass the logical part of your brain and go straight to the emotional and memory centers. This is unique among the senses. Your vision and hearing go through the thalamus first, which is more of a relay center, but smell goes directly where it matters. 14. You cannot actually taste sweetness, saltiness, or bitterness. The way you think you do, your tongue is covered with taste buds, and within each taste bud are taste receptor cells. Most people think that different areas of the tongue are responsible for different tastes, but that's a common misconception. You have 5 basic types of taste receptors distributed across your entire tongue: sweet, salty, sour, bitter, and umami. They're not localized to specific areas. These taste receptor cells are detecting chemical compounds in your food and sending signals to your brain. What you think of as tasting is actually a combination of taste, smell, and texture. When you eat something, molecules from the food travel up into your nasal cavity and are detected by your olfactory receptors. This is why food tastes bland when you have a cold and your sense of smell is compromised. Most of what you think of as taste is actually smell. The taste buds on your tongue are responsible for detecting only the 5 basic tastes, while your sense of smell is providing almost all of the nuance and complexity. Without smell, a piece of chocolate and a piece of onion might taste surprisingly similar. 15. Your stomach produces a new lining every 3 to 5 days. Your stomach is essentially a self-contained chemical reactor. It produces stomach acid that is strong enough to dissolve metal, yet your stomach doesn't digest itself. This is because your stomach cells produce a thick layer of mucus that protects the stomach lining from the acid. This mucus layer is constantly being replaced. Your stomach produces a new lining approximately every 3 to 5 days. This is one of the fastest replacement rates of any tissue in your body. If something damages this protective lining, you can develop an ulcer where the acid actually begins to eat into the stomach tissue itself. This is painful and potentially serious, but the fact that your stomach replaces its lining so frequently also means that most ulcers can heal relatively quickly once the underlying cause is addressed. Your stomach produces this fresh lining continuously as part of its normal operation. The whole system is like a carefully balanced chemical war between your stomach's acidic contents and your body's defensive mucus layer. If the balance tips, problems arise. But as long as the balance is maintained, this system works remarkably well. 16. Your liver can regenerate itself. Even if up to 75% of it is removed, your liver is perhaps the most resilient organ in your body. If a surgeon were to remove up to 75% of your liver, the remaining tissue would regenerate and grow back to almost full size. The process takes weeks, but it works. This is partly why living organ donors can donate portions of their livers to family members. The donor's liver will regenerate, and the transplanted portion in the recipient will also grow. This regenerative ability is found nowhere else in the body to this degree. Your heart can't regenerate, your brain can't regenerate, your spinal cord can't regenerate, but your liver can. The liver performs hundreds of functions in your body. It filters blood, produces bile, breaks down harmful substances, stores vitamins and minerals, and plays a role in immune function. It's remarkably multifunctional. And somehow, after removing 3/4 of this vital organ, it just grows back. This capability speaks to something about the liver that we don't fully understand. It's one of the great mysteries of biology that this particular organ has evolved such an extraordinary ability to recover. 17. You have 4 parathyroid glands smaller than a grain of rice that control your calcium levels. Hidden behind your thyroid gland, which is already a small gland that you probably don't think about much, are 4 even smaller glands called parathyroid glands. Each one is about the size of a grain of rice. Despite their diminutive size, they have an enormous job. They produce parathyroid hormone, which regulates the level of calcium in your blood. Calcium is essential for countless functions in your body: muscle contractions, nerve signals, blood clotting, bone health, and hundreds of enzymatic processes. Your blood calcium level must be maintained within a very narrow range. If it gets too high or too low, serious problems develop. Your 4 tiny parathyroid glands are constantly monitoring your blood calcium level and adjusting hormone production to keep it balanced. If calcium is too low, they release more hormone. If calcium is too high, they produce less. This is one of the most sensitive and responsive feedback systems in your body, and it's being run by organs that are barely visible to the naked eye. Many people have no idea these glands exist, yet they're working behind the scenes constantly, maintaining one of the most critical chemical balances in your body. 18. Your pancreas is both an endocrine and an exocrine organ, meaning it does 2 completely different jobs. Your pancreas is about 6 inches long and weighs about 1.5 ounces. It sits behind your stomach, mostly hidden from view. Most people know it primarily as the organ that produces insulin, which regulates blood sugar. But it does much more than that. Your pancreas is what's called a mixed gland. Part of it, called the endocrine pancreas, produces hormones like insulin and glucagon that regulate your blood sugar. This is perhaps its most famous function. But another part, called the exocrine pancreas, produces digestive enzymes that help break down food in your small intestine. These 2 parts are working simultaneously, performing completely different functions. The endocrine portion is producing hormones that go directly into your bloodstream. The exocrine portion is producing enzymes that go into ducts that eventually empty into your small intestine. It's like having 2 different organs sharing the same physical space. This dual functionality makes the pancreas a relatively common site of problems. Issues with blood sugar regulation are often pancreatic issues. Problems with digestion can also be pancreatic. And pancreatic cancer is particularly dangerous, partly because this organ is tucked away, and cancers often go unnoticed until they're advanced. 19. Your pituitary gland, which controls many other glands, is smaller than a pea. At the base of your brain sits your pituitary gland, an endocrine gland that's about the size of a pea. Despite its diminutive dimensions, it's often called the master gland because it produces and controls the release of hormones that regulate many other glands and bodily functions. Your pituitary gland produces growth hormone, which controls how tall you grow and how quickly your body develops. It produces prolactin, which stimulates milk production in mothers. It produces adrenocorticotropic hormone, which tells your adrenal glands to produce cortisol. It produces thyroid-stimulating hormone, which tells your thyroid gland to produce thyroid hormones. It produces luteinizing hormone and follicle-stimulating hormone, which regulate reproduction, and it produces vasopressin, which controls how much water your kidneys retain. This single gland, smaller than a pea, orchestrates an enormous amount of your body's physiology. Damage to the pituitary gland can disrupt all of these processes. A tumor in the pituitary can cause hormonal imbalances that affect growth, reproduction, metabolism, and stress response. Yet most people have no idea this gland exists or what it does. It's working behind the scenes, running much of your endocrine system from a location deep within your brain. 20. Your thyroid gland produces hormones that regulate your metabolism and affect almost every cell in your body. Your thyroid gland is located in your neck, and it's roughly the size of a butterfly. It produces thyroid hormones, primarily thyroxine and triiodothyronine. These hormones affect almost every cell in your body. They regulate your metabolic rate, which determines how much energy your body uses at rest. They affect your body temperature. They influence your heart rate and how forcefully your heart beats. They affect how you think and feel. They influence your mood, your energy level, and your cognitive function. They affect your digestion. They influence your bone density. They affect your reproductive system. Essentially, thyroid hormones are fundamental to how your body functions. If your thyroid produces too much hormone, you develop hyperthyroidism, and your metabolism speeds up. Your heart beats faster, you feel anxious or irritable, you lose weight despite eating normally, and you feel hot. If your thyroid doesn't produce enough hormone, you develop hypothyroidism, and your metabolism slows down. You feel tired, you gain weight, you feel cold, and your thinking becomes sluggish. This small gland wields enormous power over your physiology and psychology. 21. You cannot remember most of your dreams because your brain stops producing certain neurotransmitters during REM sleep. During REM sleep, when most dreaming occurs, your brain stops producing adequate amounts of norepinephrine, a neurotransmitter that's crucial for memory formation. This is why you forget dreams. You're not forgetting because dreams are inherently forgettable. You're forgetting because your brain is actively not producing the chemicals necessary to lock the dream into memory. If you wake up immediately after a dream, you might remember it because you're catching it before it fully dissipates. But if you sleep through the night and wake up later, that dream is likely gone. This is actually adaptive. If you remembered every dream vividly and in detail, you'd be carrying around countless bizarre, sometimes disturbing, often completely nonsensical memories. Your mind is probably better off not cluttering itself with all of that material. Dreams are thought to serve various functions: processing emotions, consolidating memories, simulating scenarios, but you don't necessarily need to remember them to benefit from them. The fact that you don't remember dreams is a feature, not a bug. 22. Your brain waves change predictably as you fall asleep, moving through distinct stages. When you're awake and alert, your brain produces beta waves at a frequency of about 14 to 30 cycles per second. As you start to relax and become drowsy, your brain shifts to alpha waves at about 8 to 12 cycles per second. This is that state where you're not quite asleep but not fully awake either. Then, as you drift off to sleep, your brain moves into theta waves at about 4 to 8 cycles per second. In deep sleep, your brain produces delta waves at less than 4 cycles per second. These are the slowest brain waves you produce, and they're associated with restorative sleep. REM sleep, when you're dreaming, actually looks different. Your brain waves during REM resemble waking brain waves more than they resemble the slow waves of deep sleep, yet you're asleep and largely paralyzed. The changes in your brainwave patterns are so predictable that they can be measured and recorded. Scientists can tell what stage of sleep you're in just by looking at your EEG. Your brain is basically cycling through these different states throughout the night, spending roughly 25% of sleep in REM and the rest in non-REM sleep, cycling through the stages multiple times. 23. Your brain actually shrinks when you sleep. During sleep, your brain shrinks. The neurons lose fluid and become smaller. This creates space between cells, and cerebrospinal fluid flows through these spaces more freely. This is part of your brain's cleaning cycle. During waking, your brain is focused on processing information and dealing with the world around you. During sleep, it switches gears and focuses on maintenance. Metabolic waste products that accumulated during the day are flushed out. Memories are processed and consolidated. Your brain essentially takes itself offline for maintenance. The shrinking that occurs during sleep allows your brain to clear out these metabolic waste products more efficiently. This is one of the reasons sleep is so important. Without adequate sleep, these waste products accumulate. Over time, this accumulation is thought to contribute to cognitive decline and possibly to neurodegenerative diseases like Alzheimer's. Your brain doesn't shrink because it's damaged or unhealthy. It shrinks as part of its normal necessary maintenance process. 24. Your sinuses are mucus-producing cavities inside your skull that help warm and humidify air you breathe. You have sinuses inside your skull. They're hollow spaces within the bones of your face and head. They're lined with mucus-producing tissue. Most people think of sinuses primarily in the context of sinus infections or allergies, but they serve important functions. They help warm and humidify the air you breathe before it reaches your lungs. They reduce the weight of your skull by being filled with air rather than solid bone. They provide insulation for your brain, and they produce mucus that drains into your nasal passages, helping to keep your nasal passages moist and clear of debris. When you have a cold, your sinuses produce excess mucus, and if the drainage pathways become blocked, you feel that pressure and congestion. But when everything is working normally, your sinuses are quietly doing their job without you being aware of them at all. The sinuses are connected to your nasal passages through small openings, and they drain continuously. You don't consciously notice this drainage most of the time. 25. Your lungs have an internal surface area, roughly equivalent to a tennis court. Your lungs are composed of millions of small air sacs called alveoli. These tiny sacs dramatically increase the surface area available for gas exchange. While your lungs themselves are only about the size of your fists, the total internal surface area of your lungs is approximately 70 square meters, or about the size of a tennis court. This enormous surface area is necessary for efficient gas exchange. Oxygen needs to be able to cross from the air in your lungs into your blood. Carbon dioxide needs to be able to cross from your blood into the air. With such a large surface area, this exchange happens efficiently. Each alveolus is surrounded by tiny blood vessels called capillaries. Oxygen crosses from the alveolus into the blood in the capillary. Carbon dioxide crosses from the blood into the alveolus. The blood then carries the oxygen throughout your body and brings the carbon dioxide back to the lungs to be exhaled. If you were to actually expand and smooth out all of your lung tissue, the surface area would be staggering. This is why smoking is so damaging. It damages these delicate tissues and reduces the surface area available for gas exchange. 26. You take about 20,000 breaths per day without thinking about it. Most of the time, you're not aware that you're breathing. Your breathing is automatic. Your brain's respiratory center, located in the medulla, monitors your blood's oxygen and carbon dioxide levels and automatically adjusts your breathing rate. When you exercise and your muscles produce more carbon dioxide, your breathing rate increases automatically. You don't have to think about it. When you're resting, your breathing slows. You're not consciously controlling this. On average, you take about 16 breaths per minute when you're at rest. That's roughly 1,000 breaths per hour, or about 24,000 breaths per day. The exact number varies depending on your activity level and your fitness. Athletes often have slower resting breathing rates because their lungs are more efficient. Breathing is partially voluntary, which is unusual for an automatic process. You can deliberately hold your breath or breathe faster, but ultimately, the automatic control takes over. You cannot voluntarily stop breathing indefinitely. Your carbon dioxide levels will rise and your oxygen levels will fall, and your brain will override your voluntary control and make you breathe. 27. Your diaphragm is a dome-shaped muscle that does 75% of the work of breathing underneath your lungs. Separating your chest from your abdomen is a muscle called the diaphragm. It's dome-shaped when relaxed. When you inhale, your diaphragm contracts and flattens out, moving downward. This increases the volume of your chest cavity, which decreases the pressure inside your lungs, which causes air to flow in. Your diaphragm does most of the work of breathing. It's responsible for about 75% of the effort required to inhale. The intercostal muscles between your ribs help, but they're playing a supporting role. Most people don't think about their diaphragm much unless they experience something like hiccups, which are involuntary diaphragm contractions. When your diaphragm contracts suddenly and involuntarily, your vocal cords snap shut and you make that characteristic hic sound. Most of the time, your diaphragm is working automatically and silently, constantly contracting and relaxing as you breathe. People with respiratory issues often have diaphragm problems. Athletes sometimes train their diaphragm to breathe more efficiently, but for most people, their diaphragm works without any conscious awareness. 28. You produce about 1 to 1.5 liters of mucus per day in your respiratory system. Your respiratory system is lined with a mucus-producing tissue called mucosal tissue. You produce roughly 1 to 1.5 liters of mucus every single day in your nose, sinuses, throat, and lungs. This might sound like a lot, and it is, but it's all serving an important purpose. The mucus traps particles, bacteria, and viruses. It keeps your respiratory tract moist. It has antimicrobial properties that help protect you against infection. The mucus is continuously being produced and then either swallowed or expelled. When you have a cold or allergies, your respiratory system produces even more mucus, which is why you get congested. The excess mucus can feel uncomfortable, but it's your body's defense mechanism at work. The mucus is working to trap the virus or allergen and prevent it from infecting your cells or reaching deeper into your lungs. Most of the time, you're not aware of the mucus you're producing and constantly swallowing. It's part of your body's background maintenance. 29. Your stomach can stretch to hold up to 4 liters of food and liquid. When you're not eating, your stomach is roughly the size of a closed fist, holding perhaps 50 milliliters of liquid. But when you eat a large meal, your stomach can stretch dramatically. It can expand to hold up to 4 liters of food and liquid without being damaged. This stretching happens because the stomach walls are elastic and contain specialized muscle fibers that allow for this expansion. As your stomach fills and stretches, stretch receptors in the stomach wall send signals to your brain indicating fullness. This is how you know when to stop eating. The more your stomach stretches, the more full you feel. Interestingly, larger people often have larger stomach capacities, and frequent overeaters can gradually stretch their stomachs to hold more. This is one reason why weight loss can be difficult for people who are used to eating large quantities. Their stomachs have adapted to those volumes. Conversely, people who eat smaller portions consistently often find that they feel satisfied with less food because their stomachs haven't stretched as much. Your stomach is designed to be flexible and accommodate varying meal sizes, but this flexibility has consequences for appetite regulation. 30. Your small intestine is about 20 feet long, but it's folded and coiled to fit inside your abdomen. If you were to take your small intestine and stretch it out straight, it would be about 20 feet long, yet it fits inside your abdomen without taking up excessive space because it's folded, coiled, and arranged in a very specific way. Your small intestine is divided into 3 sections: the duodenum, the jejunum, and the ileum. Most of the absorption of nutrients happens in your small intestine. The inside of your small intestine is covered with millions of tiny finger-like projections called villi. Each villus is covered with even tinier projections called microvilli. This creates an enormous surface area for nutrient absorption. The The structure of your small intestine is optimized for absorbing as many nutrients as possible from the food you eat. The folding and coiling allows for this tremendous length to fit within your abdominal cavity. If your small intestine were a simple, straight tube, you'd need a much larger abdomen to accommodate it. Instead, it's arranged in a way that maximizes space efficiency while maintaining the length needed for thorough nutrient absorption. 31. Your colon absorbs about 1 to 2 liters of water every day from waste material. By the time food reaches your colon, most of the nutrients have already been absorbed in your small intestine. What's left is mostly waste material and water. Your colon has an important job. It absorbs water from this waste material. It absorbs approximately 1 to 2 liters of water every single day. This water absorption is crucial. It concentrates the waste material into feces. If your colon didn't absorb this water, your stool would be very loose or liquid. You'd have diarrhea constantly. Conversely, if your colon absorbs too much water, the waste material becomes too dry and hard, leading to constipation. The movement of waste through your colon is controlled by muscle contractions and is regulated partly by diet, hydration, and your nervous system. Stress and anxiety can affect your colon's function, which is why many people experience digestive issues during stressful periods. Your colon is also home to trillions of bacteria that make up your gut microbiome. These bacteria produce vitamins, particularly B vitamins and vitamin K, which your colon absorbs. So your colon isn't just absorbing water, it's absorbing nutrients produced by your bacterial residents. 32. You have about 100 trillion bacteria living in and on your body. You contain roughly 100 trillion bacteria. This is roughly the same number as the number of human cells in your body. In other words, you're about 1% human cells and 99% bacterial cells by number. Most of these bacteria live in your colon. Collectively, they weigh about 2 to 3 pounds. These bacteria, collectively called your microbiome, perform essential functions. They produce vitamins that you need. They help digest certain types of fiber that your own enzymes can't break down. They produce compounds that strengthen your intestinal barrier. They play a role in your immune system. They influence your mood and mental health. Damage to your microbiome through extended antibiotic use or poor diet can have far-reaching consequences for your health. There's growing evidence that your microbiome influences everything from your mood to your weight to your vulnerability to certain diseases. You're not as individual as you might think. You're part symbiotic organism, living in partnership with trillions of bacteria. In a very real sense, you are more bacteria than human. 33. Your immune system contains white blood cells that can distinguish between self and non-self. Your immune system has an extraordinary job. It needs to protect you from harmful invaders like bacteria, viruses, and parasites while not attacking your own cells. White blood cells are the frontline soldiers of your immune system. There are several types of white blood cells, each with different functions. T cells can recognize and destroy infected cells. B cells produce antibodies that mark pathogens for destruction. Macrophages engulf bacteria and debris. Neutrophils are the most abundant white blood cells and are deployed in large numbers when you have an infection. Your white blood cells can somehow distinguish between your own cells and foreign invaders. This is an incredibly sophisticated process. Your cells have markers on their surface that identify them as self. Your immune system learns to recognize these markers early in life. Anything without these markers or with different markers is recognized as potentially dangerous and can be attacked. Sometimes this system malfunctions. Autoimmune diseases occur when your immune system attacks your own cells. Your immune system is constantly working, patrolling your body, clearing away dead cells, and looking for anything that shouldn't be there. 34. You have 2 types of lymphoid tissues, lymph nodes and the spleen, which filter your blood and lymph. Throughout your body, you have small bean-shaped organs called lymph nodes. They're connected by lymphatic vessels. These vessels carry lymph, a clear fluid that contains white blood cells and other immune components. Your lymph nodes filter this lymph, removing bacteria, viruses, and dead cells. When you have an infection, the lymph nodes that drain the infected area often become swollen and tender as they work to clear the infection and produce more white blood cells. You've probably experienced this. When you have a throat infection, your neck lymph nodes might swell. When you have an infection on your hand or arm, the lymph nodes in your armpit might swell. This swelling is a sign that your immune system is working. Your spleen is a larger lymphoid organ located in your upper left abdomen. It also filters blood, removing old red blood cells and pathogens. It produces white blood cells. It stores red blood cells and platelets. If your spleen is damaged or removed, you can still survive, but you become more vulnerable to certain infections. Your spleen and lymph nodes work together to help keep your body clean and protected. 35. Your bone marrow, hidden inside your bones, produces about 200 billion red blood cells. Every single day, inside your bones is a tissue called bone marrow. It's a soft, spongy tissue where blood cells are produced. Your bone marrow produces roughly 200 billion red blood cells every single day. Red blood cells only live for about 120 days, so your bone marrow is constantly working to replace them. Your bone marrow also produces white blood cells and platelets. This production is called hematopoiesis. Your body needs this constant production to maintain adequate supplies of blood cells. If your bone marrow is damaged or isn't functioning properly, you can develop anemia from insufficient red blood cells, infections from insufficient white blood cells, or bleeding problems from insufficient platelets. Bone marrow is also where developing blood cells are screened before being released into circulation. Immature or defective cells are generally destroyed before they enter your bloodstream. This quality control is crucial. Cancer of the blood cells, such as leukemia, develops when cells in the bone marrow become malignant and reproduce uncontrollably. The sheer volume of blood cells your bone marrow produces daily is staggering. Billions upon billions of new cells are being created constantly. 36. Your red blood cells don't have a nucleus, which means they can't repair themselves or divide. Red blood cells are unusual among cells in that they don't have a nucleus. They don't contain DNA. They don't have mitochondria. They don't have ribosomes. They're essentially a bag of hemoglobin, the protein that carries oxygen. Because they lack a nucleus and the machinery to repair damage or divide, red blood cells cannot fix themselves if they become damaged. They cannot create new cells through division. When a red blood cell is damaged, it's removed from circulation and destroyed. This is why your bone marrow needs to produce 200 billion new red blood cells daily. Your red blood cells are expendable. They're designed to have a relatively short lifespan of about 120 days. They work hard, carrying oxygen throughout your body, and then they're replaced. This design makes sense. Red blood cells would be expensive to produce if they had all the cellular machinery that other cells have. By stripping them down to their essential components, they're cheaper to produce, and they take up less space. A red blood cell is essentially a specialized delivery vehicle for hemoglobin, nothing more. 37. Your blood has 4 main components: plasma, red blood cells, white blood cells, and platelets. Your blood is composed of a liquid component called plasma and various types of cells suspended within it. Plasma is mostly water, but it also contains proteins, salts, nutrients, and hormones. Red blood cells make up the majority of your blood cells. They carry oxygen. White blood cells are relatively rare, making up only about 1% of your blood cells, but they're enormously important for fighting infection. Platelets are fragments of cells that are crucial for clotting. If you cut yourself and start bleeding, platelets aggregated at the wound, forming a plug. They also release chemicals that activate clotting factors, which form fibrin strands that create a mesh-like clot. Without adequate platelets or without functional clotting factors, you can bleed excessively from minor injuries. With too much clotting activity, you develop dangerous blood clots that can block blood vessels. The balance between bleeding and clotting is carefully regulated. The composition of your blood can tell a doctor a tremendous amount about your health. A blood test can reveal infections, nutritional deficiencies, hormone imbalances, and many other conditions. 38. Your kidneys filter about 150 quarts of blood every single day to produce about 1 to 2 quarts of urine. You have 2 kidneys, roughly the size of your fists, located on either side of your spine. Every single day, your kidneys filter about 150 quarts of blood. From this, they produce about 1 to 2 quarts of urine. That's an enormous amount of filtering. Your kidneys remove waste products from your blood, regulate your electrolyte balance, regulate your blood pressure, produce hormones that influence red blood cell production, and produce hormones that influence bone health. If your kidneys fail and can't filter waste products, those waste products accumulate in your blood. This is toxic. People with severe kidney failure need dialysis, a procedure that artificially filters their blood. Your kidneys are also involved in regulating how much water your body retains. The hormone vasopressin, produced by your pituitary gland, makes your kidneys more permeable to water. When vasopressin levels are high, your kidneys reabsorb more water, so you produce less urine. When vasopressin levels are low, your kidneys reabsorb less water, so you produce more urine. This is how your body maintains proper hydration. If you drink a lot of water, vasopressin levels drop, and you produce more urine. 39. Your bladder can hold about 400 to 600 milliliters of urine before you feel the urge to urinate. Your bladder is a muscular organ that stores urine. It can expand to hold about 400 to 600 milliliters of urine before you feel a strong urge to urinate. This translates to roughly 13 to 20 ounces. When your bladder is full and the stretch receptors in the bladder wall send signals indicating fullness, you become aware that you need to urinate. Urination is controlled by muscles called the urinary sphincters. The internal urinary sphincter is under involuntary control. The external urinary sphincter is under voluntary control. In children, both sphincters are underdeveloped, which is why babies wet themselves involuntarily. As children grow, they develop control over the external sphincter and learn to hold their urine and choose when to urinate. If your internal sphincter is damaged or weakened, you might experience urinary incontinence. This can happen for various reasons: pregnancy, age, spinal cord injury, or neurological conditions. The bladder is an organ most people take for granted unless something goes wrong with it. 40. Your bones are constantly being remodeled, with old bone being broken down and new bone being created. Your bones might seem static and unchanging, but they're actually in a state of constant renovation. Bone cells called osteoblasts create new bone. Bone cells called osteoclasts break down old bone. This process, called bone remodeling, happens constantly. Your skeleton is completely rebuilt roughly every 7 to 10 years. The old bone material is broken down and absorbed, and new bone material takes its place. This remodeling allows your bones to adapt to stresses placed on them. If you exercise regularly and put stress on your bones, they respond by becoming stronger. If you're immobile for an extended period, your bones weaken. Astronauts in space, where there's no gravity to create stress on bones, experience significant bone loss. This is why exercise is so important for bone health, especially as you age. Calcium and vitamin D are crucial for bone remodeling because calcium is the primary mineral that makes up bone, and vitamin D helps regulate calcium absorption. Without adequate calcium and vitamin D, bone remodeling becomes imbalanced. More bone is being broken down than being created, leading to weakened bones and increased fracture risk. 41. You have 206 bones in your adult body, but you were born with about 270. When you were born, you had about 270 bones. Many of these were made of cartilage, a flexible material that's less dense than bone. As you grew, many of these bones fused together. For example, your spine is made up of many vertebrae that are separate bones, but some bones in your skull that were separate at birth have fused together by adulthood. Also, bones in your pelvis and spine that were separate as a child have fused by adulthood. By the time you reach adulthood, you have 206 bones. This number is approximate because some anatomical variation exists between individuals. The reduction in bone number is part of your body's development. The process of ossification, where cartilage is replaced by bone, continues into your 20s and early 30s. Long bones in your limbs continue to increase in length through childhood and adolescence until the growth plates at the ends of these bones close, usually in your mid to late teens. After that, you stop growing taller. Your bones then maintain roughly the same shape and size, though they continue to be remodeled internally. 42. Your muscles account for about 40% of your body weight in adult men and about 32% in adult women. Your muscles are a substantial portion of your body. In adult men, muscles typically make up about 40% of body weight. In adult women, they typically make up about 32%. This percentage decreases as you age, particularly after age 50. Aging is associated with gradual loss of muscle mass, a process called sarcopenia. This is part of the natural aging process and occurs in everyone to some degree. However, exercise, particularly resistance training, can slow this process significantly. Muscle loss contributes to weakness and increased fall risk in older adults. Your muscles are composed of muscle fibers, which are long, thin cells that contain contractile proteins called actin and myosin. When your brain sends a signal down a nerve to a muscle, it triggers the release of acetylcholine, which causes the muscle fiber to contract. Thousands of muscle fibers contracting together produce the muscle contraction you're aware of. Muscle fibers can be trained and adapted. With resistance training, muscle fibers grow larger, a process called hypertrophy. With endurance training, muscle fibers become more efficient at using oxygen and storing energy. Your muscles are constantly adapting to the demands placed on them. 43. Your tendons connect muscle to bone, while ligaments connect bone to bone. Tendons and ligaments are both made of collagen, a tough, flexible protein, but they serve different purposes. Tendons connect muscle to bone. When your muscle contracts, the tendon transmits the force to the bone, causing the bone to move. Ligaments connect bone to bone. They provide stability to joints by restricting the movement of bones relative to each other. Both tendons and ligaments can be injured. A sprained ankle is an injury to the ligaments in your ankle. A torn rotator cuff is an injury to the tendons around your shoulder. Tendons and ligaments have relatively poor blood supply compared to many other tissues, which is why injuries to these structures often heal slowly. They also have fewer nerve endings than muscles, which is why you might not immediately realize you've injured a tendon or ligament. By the time pain signals reach your brain, you might have already caused additional damage. Proper rehabilitation after tendon or ligament injuries is crucial because these structures need to regain their strength and flexibility to function properly. 44. You have more than 600 muscles in your body, and they work together in coordinated groups. You have over 600 muscles in your body. They range from very large, powerful muscles like your quadriceps in your thighs to very small, delicate muscles that control your eye movements. Muscles rarely work in isolation. They work in groups. When you perform a movement, one muscle or group of muscles contracts to produce the movement, while another muscle or group of muscles relaxes to allow that movement. Muscles that work together to produce a movement are called synergists. Muscles that oppose a movement are called antagonists. For example, when you bend your elbow, your biceps contracts and your triceps relaxes. When you straighten your elbow, your triceps contracts and your biceps relaxes. The coordination of these muscles is controlled by your nervous system. Your brain sends signals down nerves that tell specific muscles when to contract and how forcefully. This coordination is so automatic that you don't have to consciously think about it, yet it's incredibly complex. Learning a new motor skill, like learning to play an instrument or learning a sport, involves training your nervous system to coordinate your muscles in new ways. 45. Your nervous system is divided into the central nervous system and the peripheral nervous system. Your nervous system has two main divisions, the central nervous system and the peripheral nervous system. Your central nervous system consists of your brain and spinal cord. Your peripheral nervous system consists of all the nerves outside your central nervous system. The peripheral nervous system is further divided into the somatic nervous system, which controls voluntary movement, and the autonomic nervous system, which controls involuntary functions like heart rate, digestion, and blood pressure. The autonomic nervous system is further divided into the sympathetic nervous system, which activates your fight or flight response during stress, and the parasympathetic nervous system, which promotes rest, digestion, and recovery. These two systems are often in opposition. Your sympathetic nervous system increases your heart rate and diverts blood to your muscles. Your parasympathetic nervous system decreases your heart rate and promotes digestion. Most of the time, these systems work together to maintain balance. During stress, your sympathetic nervous system dominates. During rest, your parasympathetic nervous system dominates. This balance is crucial for your health. 46. Your spinal cord is about 18 inches long and contains about 31 pairs of spinal nerves. Your spinal cord runs from the base of your brain down through your spine. It's about 18 inches long. It's the main pathway for signals between your brain and the rest of your body. Damage to your spinal cord can result in paralysis because signals can't travel past the damaged area. Your spinal cord contains 31 pairs of spinal nerves that branch off and extend to your entire body. Each pair of spinal nerves contains sensory nerves that carry information from your body to your spinal cord and brain, and motor nerves that carry commands from your brain to your muscles. Some reflexes bypass the brain entirely. If you touch something hot, sensory nerves in your hand carry a signal to your spinal cord. The signal connects with motor nerves in your spinal cord, which immediately tell your hand to pull away. This happens before the signal even reaches your brain. You jerk your hand away before you're even consciously aware that something was hot. This spinal reflex is an evolutionary adaptation that protects you from injury. Your brain becomes aware of the hot object after you've already pulled your hand away. 47. You have about 7 trillion nerve endings throughout your body that detect touch, temperature, and pain. Nerve endings are specialized structures that detect sensations. You have about 7 trillion nerve endings throughout your body. Some are sensitive to touch, some to temperature, and some to pain. Different areas of your body have different densities of nerve endings. Your fingertips have many nerve endings, which is why your fingers are very sensitive and good at detecting fine details. Your back has fewer nerve endings, which is why you might not notice a light touch on your back, but you definitely notice a pinprick. Pain receptors, called nociceptors, are actually quite simple. They don't detect pain directly, they detect potentially harmful stimuli. Tissue damage, extreme temperature, or extreme pressure all activate nociceptors. These nociceptors send signals to your brain indicating that something potentially harmful is happening, and your brain interprets this as pain. This is an important distinction. Pain is a brain interpretation of nociceptor signals. If your spinal cord is cut, nociceptors below the injury will still fire, but you won't feel pain because the signals can't reach your brain. Pain is a conscious experience that occurs in your brain, not in the body part where the injury occurred. 48. Your hair and nails grow continuously throughout your life, though the rate of growth decreases with age. Your hair grows about ½ an inch per month, though this varies based on genetics, age, nutrition, and overall health. Hair grows continuously from follicles rooted in your scalp. Each hair has a lifespan of about 2 to 7 years before it falls out, and is replaced by a new hair. Your nails grow at a slightly slower rate, about 0.1 inches per week, or roughly half an inch per month. Like hair, nails grow from a region called the matrix, located under the skin at the base of your nail. The white crescent-shaped area at the base of your nail, called the lunula, is actually just the visible part of the matrix. As new keratin cells are produced in the matrix, they push the older cells forward, and this produces the appearance of nail growth. Both hair and nails are made of a protein called keratin, which is very tough and not living tissue once it emerges from your skin. When you cut your hair or nails, you're not cutting living tissue, you're cutting dead protein. This is why it doesn't hurt. Hair and nail growth are influenced by your nutritional status. With adequate protein, iron, and other nutrients, your hair and nails grow healthily. With poor nutrition, hair and nail growth can slow, or the hair and nails can become weak and brittle. 49. Your eyes can distinguish between about 10 million different colors, though most people can only consciously distinguish a few thousand. Your eyes contain 3 types of cones, each sensitive to different wavelengths of light. One type is primarily sensitive to red wavelengths, one to green, and one to blue. All other colors you perceive are combinations of these 3 primary colors. Your brain can distinguish between about 10 million different colors by analyzing the signals from these 3 types of cones. However, most people can only consciously distinguish a few thousand different colors. Some people, primarily women, possess a genetic variation that gives them 4 types of cones. These individuals, called tetrachromats, can potentially distinguish between 100 million different colors. There are tests to determine if you're a tetrachromat, but most tetrachromats don't actually perceive dramatically more colors in everyday life. The increased color discrimination is most noticeable when comparing subtle shades. People with color blindness lack 1 or more types of cones. The most common form of color blindness is red-green color blindness, where the cones sensitive to red or green are either absent or not functioning properly. This affects about 8% of men and 0.5% of women. People with color blindness perceive the world in different colors than people with normal vision, and they often don't realize this until it's pointed out to them. 50. Your body's sense of balance and spatial orientation is maintained by a complex integration of your visual system, your vestibular system, and your proprioceptive system. Your sense of balance and your awareness of where your body is in space comes from 3 different systems working together. Your visual system tells you where the world is and where you are in relation to it. Your vestibular system, located in your inner ear, detects motion and gravity. Your proprioceptive system, which consists of specialized sensors in your muscles and joints, tells you where your body parts are relative to each other. When all 3 systems are in agreement, you feel balanced and oriented. When they conflict, you feel dizzy or disoriented. This is what happens with motion sickness. Your eyes tell you the vehicle is stable, but your vestibular system detects motion. This conflict creates nausea and dizziness. People who lose function in one of these systems often develop problems with balance. Someone who loses vestibular function might experience extreme vertigo until their brain learns to compensate by relying more heavily on visual and proprioceptive information. Someone who loses proprioceptive function might struggle to coordinate movement and feel unsteady, especially in low light conditions when they can't rely on visual information. Your brain is constantly integrating information from these 3 systems to maintain your sense of balance and spatial orientation. It's a complicated process that happens automatically and silently in the background. 51. Your fingernails contain no living cells, yet they can still show signs of disease and nutritional deficiency. The part of your fingernail you can see and feel, the nail plate, is made entirely of dead keratin cells. There's no blood flowing through it, no nerves, no living tissue, Yet your nails can still tell a remarkable story about your health. Certain patterns or discolorations on your nails can indicate nutritional deficiencies. White spots might indicate zinc deficiency. Horizontal ridges might indicate stress or illness. Clubbed nails, where the fingertip becomes enlarged and the nail curves downward, can indicate lung disease or heart disease. Pale nails might indicate kidney disease or liver disease. Yellow nails might indicate fungal infection or certain respiratory conditions. The nail matrix, the living tissue under your skin where nails grow, is responsive to your overall health. If your health is compromised during the time a section of nail is being produced, that damage gets recorded in the nail. Months later, when that section of nail has grown out and become visible, it reveals what was happening in your body at the time it was produced. Your nails are essentially a record of your recent health history written in keratin. 52. Your ears never stop growing. Throughout your entire life, unlike most parts of your body, your ears continue to grow throughout your entire life. This happens for a few reasons. The cartilage in your ears, like all cartilage, continues to be deposited as you age. Additionally, gravity constantly pulls on your ears, elongating them. Your earlobes in particular tend to stretch and elongate over the years. By the time you're elderly, your ears might be noticeably larger than they were in your youth. Studies have shown that on average, ears grow about 0.22 millimeters per year. This might seem insignificant, but over 70 or 80 years, it adds up. Your nose also continues to grow throughout your life for similar reasons. The cartilage continues to grow and gravity pulls downward on the nasal tissues. This is one reason why elderly people often appear to have larger noses and ears compared to their youth. Your ears and nose are among the few things that keep growing right up until you die. Most other body parts reach their maximum size in adulthood and then remain relatively stable or actually shrink with age. 53. You cannot hum while holding your nose closed. Try it. Close your nose and try to hum. You'll find that you can't. Humming requires air to vibrate your vocal cords and then escape through your nose. If your nose is blocked, that air can't escape, and you can't produce the characteristic sound of humming. You can make other sounds. You can talk. You can whistle. But humming specifically requires nasal airflow. This is because humming is produced by your vocal cords vibrating while your mouth is closed. The sound needs somewhere to exit, and if your mouth is closed, the only exit is through your nose. This simple fact reveals something about how your body produces sound. Your voice, your humming, your whistling, all of these require the right combination of airflow, vibration, and anatomical structures. Block any part of this pathway, and the sound changes or disappears entirely. If you have chronic nasal obstruction from allergies or a deviated septum, you might notice that you can't hum as easily as other people. Your nasal passages are part of your sound production system, not just for breathing and smelling. 54. Your stomach acid is strong enough to dissolve metal, yet it doesn't dissolve your stomach. The hydrochloric acid in your stomach has a pH of about 1.5 to 3.5, which is incredibly acidic. This acid can dissolve many metals, yet it doesn't dissolve your stomach. This is protected by a thick layer of mucus and by the fact that your stomach cells are constantly renewing themselves. Additionally, your stomach produces bicarbonate, a base that neutralizes acid close to the stomach lining. This creates a gradient where the acid is very strong in the center of your stomach, but becomes progressively less acidic as you approach the stomach wall. Once food leaves your stomach and enters your small intestine, the acid must be neutralized. Your pancreas produces bicarbonate that is released into your small intestine to neutralize the stomach acid. If this neutralization doesn't happen properly, or if stomach acid backs up into your esophagus, you get acid reflux or heartburn. Your esophagus, unlike your stomach, doesn't have the protective mucus layer, so stomach acid causes pain and can cause damage to the esophageal tissue over time. This is why chronic acid reflux is concerning and should be addressed. 55. Your tongue is unique to you, like your fingerprints. Your tongue has a unique pattern of ridges and grooves that is as individual to you as your fingerprint. No two people have the same tongue print. Law enforcement and security organizations have explored the possibility of using tongue prints for identification, similar to how fingerprints are used. In practice, fingerprints are more commonly used because they're easier to capture and analyze, but tongue prints are theoretically just as unique. Your tongue is an incredibly complex organ. It contains 8 different muscles, 4 intrinsic muscles, and 4 extrinsic muscles. The intrinsic muscles change the shape of the tongue. The extrinsic muscles move the tongue around. These muscles work together to allow you to position your tongue precisely for speaking, eating, and swallowing. Different cultures and languages use the tongue in different ways. Speakers of tonal languages, like Mandarin Chinese, use precise tongue positioning to create different tones. Speakers of languages with many sibilant sounds need to position their tongue precisely for correct pronunciation. People who are deaf from birth and learn sign language often move their tongue while signing, possibly as a residual motor pattern from attempting to use multiple modalities simultaneously. 56. Your eyes take a fraction of a second to see, but your brain takes much longer to process what you're seeing. Light hits your retina almost instantaneously. Your photoreceptor cells respond within milliseconds. The signal travels through your retina and down your optic nerve. But your brain takes time to process this information. There's a lag between when light hits your eye and when you consciously perceive what you're seeing. This lag is typically about 80 to 100 milliseconds, or about 1/10 of a second. Your brain compensates for this lag by predicting where things will be based on their trajectory. When you watch a fast-moving object, your brain isn't actually showing you where the object is right now. It's showing you where your brain predicts the object will be. This prediction system works well most of the time, but it can be fooled. Magic tricks often exploit this lag and these predictive tendencies. Sleight of hand works because your brain fills in the gaps and doesn't actually see the precise moment when the magician moves the object. Your conscious perception of the world is actually a reconstructed version of reality, not reality itself. Your brain is constantly filling in gaps, making predictions, and constructing the experience you have of the world. 57. Your heart can beat independently of your brain, which is why hearts can be kept beating outside the body. Your heart contains its own electrical system. The sinoatrial node, located in the wall of your right atrium, generates the electrical impulses that cause your heart to beat. While your brain can modulate the heart rate through the autonomic nervous system, it's not essential for the basic heartbeat to occur. This is why hearts can continue beating even after the brain has completely stopped functioning, and why hearts can be kept beating outside the body using appropriate solutions and mechanical support. Surgeons can remove a heart from a donor, keep it in a special solution, and transport it to a recipient. During this time, the heart isn't in the body and isn't connected to the brain, yet it continues beating. This remarkable autonomy is unique among your vital organs. Your lungs won't breathe without brain and spinal cord signals. Your kidneys won't filter without being perfused with blood, but your heart will keep beating on its own. This is actually a remnant of evolutionary development. Early life forms in our evolutionary history had hearts before they had brains. The basic pacemaker function of the heart is an ancient feature that's been retained even as more sophisticated control systems have evolved. 58. Your body temperature varies throughout the day by about 1 to 2 degrees Fahrenheit, following a circadian rhythm. Your body doesn't maintain a perfectly constant temperature. It varies throughout the day in a predictable pattern called a circadian rhythm. Your temperature is typically lowest in the early morning hours, around 4 to 5 a.m. when you're deep in sleep. It gradually rises throughout the day, reaching its peak in the late afternoon or early evening, around 4 to 6 p.m. This variation is about 1 to 2 degrees Fahrenheit. This circadian temperature rhythm is controlled by your hypothalamus, the part of your brain that acts as your body's thermostat. The rhythm persists even if you're not sleeping or eating normally. Jet lag disrupts this rhythm temporarily until your body adjusts to the new time zone. This temperature rhythm is one of the reasons why you feel more energetic in the afternoon and less energetic in the early morning. It's also why infections often cause higher fever in the evening, not because the infection is worse, but because your normal circadian temperature rise amplifies the fever. Understanding this rhythm can help you schedule activities appropriately. You tend to perform better on tasks requiring strength and coordination in the afternoon when your temperature is higher. You tend to perform better on tasks requiring precision in the morning when your temperature is lower. 59. Your body produces about 200 to 500 million new red blood cells every single minute. We mentioned earlier that your bone marrow produces about 200 billion red blood cells every day. That translates to about 200 to 500 million new red blood cells being created every single minute. Every minute of every day and night, your bone marrow is running production lines that manufacture cells at this staggering rate. The reason for this enormous production is that red blood cells have a relatively short lifespan of about 120 days. Your body needs to constantly replace them. If your bone marrow is damaged or not functioning properly, this production drops, and you can develop severe anemia. With severe anemia, you don't have enough red blood cells to carry oxygen throughout your body. You become fatigued, short of breath, and pale. The rapid reproduction of red blood cells is actually visible in the blood of people with certain conditions. In people with severe anemia, you might see immature red blood cells circulating in the blood because the body is pushing out young cells to try to meet demand. The sheer volume of cell production happening in your bone marrow right now is difficult to comprehend. It's one of the most productive tissues in your body by volume. 60. Your adrenal glands produce cortisol, which increases during stress and helps your body cope with threats. Sitting atop your kidneys are two small glands called adrenal glands. They produce several important hormones, particularly cortisol. Cortisol is your stress hormone. When you encounter a stressful situation, your sympathetic nervous system signals your adrenal glands to produce more cortisol. Cortisol increases your heart rate, increases your blood pressure, increases your blood glucose, and redirects blood flow to your muscles. It essentially prepares your body for action. In the short term, this is adaptive. You need these changes to respond to a threat. But if you're under chronic stress, your cortisol levels stay elevated chronically. Chronically elevated cortisol has negative effects. It weakens your immune system, making you more susceptible to infections. It can impair your cognitive function. It can disrupt your sleep. It can increase your risk of heart disease. It can cause weight gain, particularly around the abdomen. This is why chronic stress has such a profound impact on health. Your adrenal glands are working overtime, continuously pumping out cortisol, and this sustained elevation has cascading negative effects throughout your body. Managing stress and allowing your body adequate rest and recovery time is crucial for keeping cortisol levels in a healthy range. 61. Your thymus gland is largest in childhood and gradually shrinks as you age. Your thymus gland is located in your chest, behind your breastbone. It's responsible for producing and training T cells, white blood cells that are crucial for your immune system. In children, your thymus gland is relatively large and is very active. It produces large numbers of T cells that are trained to recognize pathogens and distinguish them from your own cells. As you reach adulthood, your thymus gland begins to shrink, a process called involution. By the time you're 60 years old, your thymus is mostly replaced by fat and connective tissue. It's much smaller and far less active. This is one of the reasons why your immune system becomes less robust as you age. You have fewer new T cells being produced. The T cells you do have are often less capable because your thymus isn't training new ones. This is why older people are more susceptible to infections and why vaccines are sometimes less effective in older adults. The decline of the thymus is one of the hallmarks of aging. Some researchers are exploring ways to slow or reverse thymus decline as a potential anti-aging intervention. 62. Your immune system can remember pathogens. You've been exposed to, which is how vaccines work, your immune system has a remarkable ability to remember. If you're exposed to a particular pathogen and your immune system successfully fights it off, your immune system retains a memory of that pathogen. If you encounter the same pathogen again years or even decades later, your immune system recognizes it and responds much faster and more effectively than it did the first time. This is called immunological memory, and it's the basis for how vaccines work. A vaccine exposes your immune system to a harmless version of a pathogen, often just a piece of it or an inactivated version. Your immune system responds by producing antibodies and training T cells to recognize this pathogen. This happens without you actually getting the disease. Later, if you're exposed to the real pathogen, your immune system recognizes it immediately and destroys it before it can cause infection. This is why you typically only get certain diseases once. Your immune system remembers. This is also why some vaccines provide lifelong immunity while others need boosters. The memory cells gradually decline if they're not periodically re-stimulated. A booster vaccination re-stimulates your immune memory, keeping it sharp. 63. Your body contains about 2 pounds of lymphoid tissue spread throughout your body. In addition to your spleen and lymph nodes, you have lymphoid tissue spread throughout your body. Much of this is in your gut. You have lymphoid tissue in your tonsils, your adenoids, your appendix, and scattered throughout your intestinal lining as Pierre's patches. Collectively, all of this lymphoid tissue weighs about 2 pounds in an adult. This tissue is constantly sampling the environment, looking for pathogens. Pierre's patches in your intestines sample bacteria and antigens from your food. They help train your immune system to tolerate harmless substances while remaining alert to actual pathogens. This training happens early in life and shapes your immune system's responses for the rest of your life. Early childhood infections and the foods you're exposed to in infancy influence the development of your immune system. This is one reason why exposure to a diverse range of bacteria and antigens in childhood is actually beneficial. It trains your immune system to discriminate between harmless and harmful substances. Your lymphoid tissue is doing surveillance work constantly, monitoring and training your immune system. 64. You have about 20 different types of white blood cells, each with different specialized functions. While we often talk about white blood cells collectively, your immune system actually employs about 20 different types of white blood cells, each with specialized functions. T cells kill infected cells. B cells produce antibodies. Macrophages engulf bacteria and debris. Neutrophils are deployed in large numbers during infections. Natural killer cells kill infected or cancerous cells. Dendritic cells present antigens to other immune cells. Eosinophils fight parasitic infections. Basophils and mast cells release histamine during allergic reactions. The list goes on. Each type has specific functions and specific ways of recognizing pathogens. Some produce their own weapons, like antibodies or toxic chemicals. Some work by engulfing pathogens. Some kill infected cells by inducing them to self-destruct. Some coordinate immune responses by releasing chemical signals. Your immune system is not a simple mechanism. It's an incredibly complex network of different cell types working in coordination. When your immune system is healthy, this coordination is seamless. When it's compromised, as in certain diseases, the entire system can break down. 65. Your body has a lymphatic system that's nearly as extensive as your circulatory system, but much slower. Your lymphatic system is a network of vessels that parallels your blood vessels. It collects fluid from your tissues and returns it to your bloodstream. Unlike your blood, which is pumped by your heart, lymph moves slowly through your lymphatic vessels through muscle contraction and one-way valves. Lymph nodes filter this fluid, removing bacteria and debris. Your lymphatic system also absorbs fats from your digestive system. After you eat a fatty meal, much of that fat is absorbed into lymphatic vessels in your intestines before eventually reaching your bloodstream. Your lymphatic system is crucial for immune function and for maintaining proper fluid balance. If your lymphatic system is damaged, as can happen after surgery or radiation therapy, fluid can accumulate in tissues, a condition called lymphedema, swelling and reduced mobility result. Your lymphatic system is often overlooked in discussions of body systems, but it's enormously important. You have about twice as much lymph in your body as you have blood. Your lymphatic system is constantly working to keep you clean and protected. 66. Your bone marrow produces immune cells and stem cells, in addition to blood cells. Bone marrow produces white blood cells and stem cells alongside red blood cells and platelets. Various types of white blood cells are born in your bone marrow. B cells mature in the bone marrow before entering circulation. Other white blood cells mature in your bone marrow as well. Additionally, your bone marrow produces hematopoietic stem cells, which are cells that can differentiate into any type of blood cell. It also produces mesenchymal stem cells, which can differentiate into bone, cartilage, fat, or other tissues. Stem cells are remarkable because they can divide to create more stem cells, or they can differentiate into specialized cells. This makes them valuable for potential medical treatments. Bone marrow transplants are used to treat certain blood cancers and bone marrow disorders. The transplanted bone marrow contains stem cells that can repopulate a patient's blood cell production. Bone marrow is one of the most productive tissues in your body, generating not just blood cells, but also the stem cells that maintain this production long term. 67. Your kidneys filter your blood so thoroughly that valuable substances are filtered out and then reabsorbed. Your kidneys filter your blood so thoroughly that glucose, amino acids, and other valuable substances are initially filtered out into your urine. But these substances are too valuable to lose, so they're reabsorbed in the proximal tubule of your nephron, the functional unit of your kidney. Glucose is normally completely reabsorbed. You don't normally have glucose in your urine, but if your blood glucose is very high, as in diabetes, the glucose concentration exceeds the kidney's reabsorption capacity, and glucose spills into your urine. This is why checking for glucose in the urine can indicate diabetes. Amino acids are also normally completely reabsorbed. Protein in your urine generally indicates a kidney problem because intact proteins are too large to be filtered normally. If your kidneys are damaged and allowing proteins to leak into your urine, that's a sign of kidney disease. Your kidneys are extraordinarily selective. They filter out waste while retaining the substances your body needs. They also regulate the balance of electrolytes and the pH of your blood. The sophistication of kidney function is remarkable. 68. Your eyes produce tears, continuously to keep your eyes lubricated and protected. You produce tears all the time, not just when you're sad or emotional. Your eyes continuously produce a small amount of tears that keep your eye surface wet and protected. These tears contain lysozyme, an antimicrobial compound that helps fight infection. They contain oil produced by glands in your eyelids that helps prevent evaporation. They contain mucus that helps the tears spread evenly across your eye surface. Tears are produced by your lacrimal glands, located above your eyes. They drain through small ducts that run to your eye surface. The tears drain out of your eye through tiny openings, then down into your nasal cavity. This is why your nose runs when you cry hard. The tear drainage system connects directly to your nose. When you blink, you're spreading a fresh layer of tears across your eye and moving tears toward the drainage system. If tear production decreases, your eyes become dry and uncomfortable. This happens with age, certain medications, and certain medical conditions. Dry eye can be serious because without adequate tears, your cornea can be damaged. 69. Your cornea does most of the focusing of light, not your lens. Most people think your lens does the focusing of light in your eye, but actually your cornea does most of the work. Your cornea, the clear membrane covering the front of your eye, does about 70% of the focusing. Your lens does about 30%. Your lens does have the advantage of being able to change shape, allowing your eye to focus on objects at different distances. This ability to change lens shape is called accommodation. As you age, your lens becomes less flexible. The proteins in your lens denature and cross-link, making the lens stiffer. This is why older adults typically need reading glasses. The lens can no longer change shape enough to focus on near objects. Your cornea is remarkably tough and clear. It's composed of precisely arranged collagen fibers that allow light to pass through while providing structural support and protection. If your cornea becomes scarred or its shape is irregular, your vision is affected. Corneal transplants are sometimes performed when the cornea is damaged beyond repair. The cornea has no blood vessels, which is why it can be transplanted without the same risk of rejection as organs with blood vessels. 70. Your eyes contain fluid called aqueous humor that maintains the shape of your eye. Inside your eye, between your cornea and your lens, is a fluid called aqueous humor. This fluid maintains the shape of your eye and provides nutrients to your cornea and lens, which don't have blood vessels. Aqueous humor is continuously produced by the ciliary body and continuously drained through a structure called the trabecular meshwork. If the drainage is obstructed and aqueous humor accumulates, the pressure inside your eye increases. This is glaucoma. The increased pressure can damage your optic nerve, leading to vision loss. Glaucoma is often called the silent thief of sight because it typically causes no symptoms until significant damage has occurred. Your eye pressure can be measured during an eye exam. If it's elevated, treatment can be started to prevent damage. Your aqueous humor is different from the vitreous humor, the gel that fills the back of your eye. The vitreous humor is produced once during fetal development and isn't replaced. The aqueous humor is continuously produced and drained. This continuous circulation is important for maintaining the health of your eye. 71. Your pupils dilate in response to emotion and cognitive effort, not just light. Your pupils constrict in bright light and dilate in dim light, but your pupils also respond to your emotional state and cognitive state. When you see something you find attractive, your pupils dilate. When you're mentally engaged in a difficult task, your pupils dilate. When you're relaxed and not engaged, your pupils constrict. This is regulated by your autonomic nervous system. Your sympathetic nervous system dilates your pupils as part of your arousal response. This dilation can happen in response to emotional stimulation, even when the light hasn't changed. Some researchers have investigated whether pupil size can be used to detect attraction. A person's pupils dilate when they see someone they find attractive, even if they're trying to hide that attraction. Marketing researchers have used pupil measurement to gauge consumer responses to advertisements. Your pupils are responding constantly to your internal state as well as to external light conditions. Makeup and fashion trends have sometimes exploited this. Dark eye makeup that makes pupils appear larger has been fashionable partly because larger pupils are perceived as more attractive. 72. Your eyes have a blind spot where your optic nerve exits your eye. At the point where your optic nerve exits your eye, there's a spot with no photoreceptor cells. This is your blind spot. You don't notice it in everyday vision because your brain fills in the missing information based on the surrounding area. Additionally, your two eyes have blind spots in different locations. Your right eye's blind spot is to the right and slightly below center. Your left eye's blind spot is to the left and slightly below center. In normal binocular vision, one eye's image fills in what the other eye's blind spot missed. You can demonstrate your blind spot with a simple test. Close one eye and look at a point with your open eye. At a specific distance from that point, an object will disappear as it enters your blind spot. Then, as it continues, it will reappear as it exits the blind spot. Your brain normally doesn't allow you to notice this blind spot, but it's there. It's a small imperfection in otherwise remarkable vision. It's a reminder that what you perceive isn't an exact replica of reality. Your brain is constructing your perception, filling in gaps, and presenting you with a seamless experience. 73. You produce varying amounts of sweat. Throughout the day and year, your body regulates temperature partly through sweating. Even in cool conditions, you produce a baseline amount of sweat, about 2 to 3 quarts per day, that you might not notice because it evaporates. This is called insensible perspiration. When you're hot or exercising, your sweat production increases dramatically. In extreme conditions, you can produce up to 10 to 15 quarts of sweat per day. Sweat is produced by sweat glands located in your skin. You have about 2 to 4 million sweat glands. They're distributed throughout your body, but are more concentrated in your palms, soles of your feet, armpits, and forehead. As sweat evaporates from your skin, it removes heat from your body, cooling you. If you're in a hot, humid environment where sweat can't evaporate efficiently, you can overheat dangerously. Sweat also contains minerals like sodium and potassium. Heavy sweating can deplete these minerals, which is why athletes need to replenish electrolytes. Your sweat glands can adapt over time. People who exercise regularly in hot environments often sweat more efficiently, producing more sweat earlier in exercise to cool themselves more effectively. 74. Your body maintains core temperature relatively constant. Despite external temperature variations, your body maintains a core temperature of about 98.6 degrees Fahrenheit, with only about 1 to 2 degrees of variation throughout the day. This is remarkable considering that external temperatures can vary from below freezing to over 100 degrees Fahrenheit. Your hypothalamus acts as your thermostat, monitoring your core temperature and triggering responses to maintain it. If you're too hot, you sweat and blood vessels in your skin dilate to increase heat loss. If you're too cold, you shiver to generate heat and blood vessels in your skin constrict to reduce heat loss. This thermoregulation is so important that it takes priority over other functions. During hypothermia, when your core temperature drops below 95 degrees Fahrenheit, your body's basic functions begin to fail. Your heart becomes arrhythmic, your brain function deteriorates, and without rewarming, death occurs. Conversely, during heat stroke, when your core temperature exceeds about 104 to 106 degrees Fahrenheit, your proteins begin to denature, your organs begin to fail, and death can result. Your body's ability to maintain temperature within a narrow range is one of the most important homeostatic mechanisms you possess. 75. Your immune system learns which proteins are self versus non-self. Your immune system learns early in life which proteins are self and which are non-self. Proteins produced by your own body are generally tolerated. Proteins from bacteria, viruses, and other organisms are recognized as foreign and can be attacked. This learned distinction is called self-tolerance. It develops in the thymus and bone marrow, where immature T cells and B cells that recognize self-antigens are eliminated. Most of your immune cells learn not to attack your own cells, but sometimes this tolerance breaks down. Autoimmune diseases occur when your immune system attacks your own tissues. In rheumatoid arthritis, your immune system attacks your joints. In type 1 diabetes, your immune system attacks the insulin-producing cells in your pancreas. In lupus, your immune system attacks various tissues throughout your body. What triggers the breakdown of self-tolerance isn't fully understood. Genetic factors play a role. Environmental triggers might be involved. Sometimes it follows an infection with a pathogen that shares similar proteins with your own tissues. The factors that determine whether someone develops an autoimmune disease are still not completely understood. 76. Your pineal gland produces melatonin in response to darkness. Your pineal gland, located in the center of your brain, produces a hormone called melatonin. Melatonin production is triggered by darkness and suppressed by light. During the day, When light enters your eyes, a signal travels from your retina to your hypothalamus to your pineal gland, suppressing melatonin production. As the sun sets and darkness falls, this signal diminishes and your pineal gland begins producing melatonin. Melatonin levels rise throughout the evening, creating a signal to your body that it's time to sleep. Melatonin levels peak in the middle of the night and then decline toward morning. This is your circadian rhythm. If your sleep schedule is regular, your body produces melatonin at predictable times. If your sleep schedule is disrupted, or if you're exposed to artificial light in the evening, your melatonin production can be disrupted. This is one reason why excessive screen time before bed can interfere with sleep. The blue light emitted by screens is particularly effective at suppressing melatonin production. Melatonin supplements are sometimes used to help people with insomnia or jet lag, though the evidence for their effectiveness is mixed. 77. Your brain consumes about 20% of your body's oxygen supply, while your brain uses 20% of your body's energy. This translates to about 20% of your oxygen consumption as well. Neurons are incredibly dependent on oxygen. They can only survive a few minutes without oxygen. A brain with inadequate oxygen supply can suffer permanent damage very quickly. This is why stroke is such a medical emergency. During a stroke, a blood vessel in the brain becomes blocked, and the brain tissue beyond the blockage is deprived of oxygen. Every minute that passes results in more neurons dying. If blood flow isn't restored quickly, permanent brain damage results. This is also why sudden cardiac arrest is so dangerous. When your heart stops beating, blood stops flowing to your brain. Without oxygen, brain cells begin dying within minutes. If CPR can restart the heart and restore blood flow within a few minutes, the brain might recover with minimal damage. If it takes longer, brain damage is likely. Your brain's enormous oxygen demand is partly why you have such a rich network of blood vessels in your brain. Your brain is profoundly dependent on a constant supply of oxygenated blood. 78. Your brain contains about 86 billion neurons, but the number doesn't increase after childhood. Your brain contains about 86 billion neurons. Contrary to what was once believed, you generally don't create new neurons in most brain regions in adulthood. You're born with most of the neurons you'll ever have. There are exceptions. Your hippocampus, which is involved in memory formation, can generate new neurons throughout life. This neurogenesis is thought to be important for memory function. Additionally, your olfactory bulb, which processes smell, can generate new neurons. But most of your brain's regions contain roughly the same number of neurons throughout your adult life. What changes is the connections between neurons. Your brain's learning and adaptation happens through changes in the strength of connections between neurons and through the formation of new connections. This is called neuroplasticity. When you learn something new, the connections between neurons involved in that learning are strengthened. When you practice a skill, the neural circuits involved in that skill become more efficient. Your brain's power lies not in the number of neurons, but in their connectivity. A child has more neural connections than an adult because of a process called pruning, where unused connections are eliminated. Your adult brain has fewer connections, but they're more efficient because they've been refined through experience. 79. Your neurons communicate through chemical messengers called neurotransmitters. Neurons don't actually touch each other. Between neurons is a tiny gap called a synapse. Communication between neurons happens through chemical messengers called neurotransmitters. When a neuron fires, it releases neurotransmitters into the synapse. These neurotransmitters cross the gap and bind to receptors on the next neuron. Different neurotransmitters have different effects. Dopamine is involved in motivation and reward. Serotonin is involved in mood and is often low in depression. Acetylcholine is involved in muscle contraction and learning. GABA is inhibitory, reducing neural activity. Glutamate is excitatory, increasing neural activity. Most psychiatric medications work by altering neurotransmitter levels. Antidepressants often increase serotonin. Stimulant medications used for ADHD increase dopamine. Anti-anxiety medications often enhance GABA. Addiction involves the dopamine system. When you use addictive substances, they cause excessive dopamine release, creating a powerful reward signal. Over time, your brain adapts to this excess dopamine by reducing dopamine receptor density or reducing dopamine production. This adaptation means you need more of the substance to achieve the same effect, leading to escalating use. 80. Your circadian rhythm influences many aspects of your physiology beyond just sleep. Your circadian rhythm is more than just a sleep-wake cycle. It's a 24-hour cycle that influences your entire physiology. Your body temperature rises and falls on a daily cycle. Your hormone production follows daily patterns. Your digestive function varies throughout the day. Your immune function varies throughout the day. Your heart rate and blood pressure follow daily patterns. Essentially, you're a different physiological organism at different times of day. Eating at the wrong time relative to your circadian rhythm can interfere with digestion. Night shift workers who eat during the night while their circadian rhythm is signaling sleep time often experience digestive problems. This is one reason why shift work is associated with increased rates of gastrointestinal problems and metabolic issues. Your circadian rhythm is influenced primarily by light exposure, but also by eating times, social interaction, and exercise timing. If your circadian rhythm is disrupted, multiple aspects of your health are affected. Poor sleep is just one consequence. Metabolic problems, immune dysfunction, and increased risk of certain diseases can result from chronic circadian disruption. 81. Your body can switch between using glucose and fat as energy. Your body can use either glucose or fat as fuel. When you eat carbohydrates, they're broken down into glucose, which enters your bloodstream and can be used by your cells for energy or stored as glycogen in your liver and muscles. When you eat fat, it's broken down and stored as triglycerides. When glucose is available, your body generally preferentially uses glucose. When glucose is depleted, as during fasting or intense exercise lasting more than a few minutes, your body switches to using fat. During this switch, fat is broken down into fatty acids and glycerol. Fatty acids can be used by most cells for energy. The liver converts some fatty acids into ketone bodies, which your brain can use for energy. When you've been fasting for an extended period and your glycogen stores are depleted, your body enters ketosis, where it's primarily using fat for energy. This state is thought to have some health benefits, though research is ongoing. Different organs prefer different fuel sources. Your heart preferentially uses fat and lactate. Your brain preferentially uses glucose, but can adapt to use ketones. Your muscles are flexible and can use either glucose or fat depending on availability and exercise intensity. 82. Your metabolism slows as you age. Due to multiple factors, your metabolism gradually slows as you age. This happens for several reasons. You lose muscle mass with age, a process called sarcopenia. Since muscle tissue is metabolically active and requires energy to maintain, loss of muscle mass decreases your overall metabolic rate. Additionally, there are changes in the mitochondria, the organelles responsible for energy production in cells. Mitochondrial function declines with age, and mitochondrial DNA can accumulate damage. This means your cells become less efficient at producing energy. The combination of these factors means you require fewer calories as you age. If you maintain the same calorie intake while your metabolism slows, you'll gain weight. This is partly why weight gain is common in middle age, even without changes in eating or exercise habits. Additionally, hormonal changes occur with age. Thyroid hormone production can decrease, which further slows metabolism. In women, estrogen levels decline at menopause, which is associated with weight gain and metabolic changes. Understanding that metabolism slows with age can help explain why weight management becomes more challenging as you get older. 83. Your body can survive. longer without food than without water. You can survive for weeks without food, but only a few days without water. Water is involved in virtually every process in your body. Water is the transport medium for nutrients and waste. Water maintains your cell volume and allows cells to function. Water is necessary for digestion. Water is necessary for temperature regulation. Water participates in countless chemical reactions. When you're dehydrated, these processes become impaired. Even mild dehydration, a loss of just 1 to 2% of your body water, can impair cognitive function and reduce physical performance. Severe dehydration can be fatal. The thirst mechanism is supposed to drive you to drink water when you need it, but it's not a perfect system. Thirst can be blunted by certain medications and becomes less sensitive with age. Older adults often don't feel thirsty even when they're dehydrated. Additionally, thirst lags behind your body's actual water needs. By the time you feel thirsty, you're already somewhat dehydrated. This is why recommendations to drink water throughout the day make sense. Your body's water balance is tightly regulated by your kidneys and by hormones like vasopressin. If you drink too much water, your kidneys excrete the excess. If you drink too little, your kidneys conserve water. 84. Your body has multiple sensory systems, beyond the traditional 5 senses. Most people think of 5 senses: sight, hearing, taste, smell, and touch. But you actually have multiple additional sensory systems. Proprioception is your sense of where your body is in space. You know where your limbs are without looking because proprioceptors in your muscles and joints send this information to your brain. Interoception is your sense of your internal state. You can sense when you're hungry, when you need to urinate, when your heart is racing. These internal sensations come from specialized nerve endings distributed throughout your body organs. Vestibular sense is your sense of balance and movement, which we discussed earlier. Thermoception is your sense of temperature. You have separate receptors for warmth and cold distributed throughout your skin. The traditional 5 senses are the most obvious, but these additional sensory systems are crucial for your functioning. Without proprioception, you couldn't coordinate your movements. Without interoception, you wouldn't notice important bodily states. Without vestibular sense, you'd be constantly dizzy and disoriented. These systems work together to give you a complete picture of your internal and external environment. 85. Your skin functions as both a protective barrier and a sensory organ. Your skin is your body's primary barrier against the outside world. It prevents water loss. It prevents pathogenic organisms from entering your body. It provides mechanical protection. But it's also a sensory organ. Your skin contains millions of nerve endings of different types. Some are sensitive primarily to sustained pressure. Some are sensitive to vibration. Some are sensitive to light touch. Some are sensitive to temperature change. Some are sensitive to pain. Different types of endings are located at different depths in your skin. This distributed system allows you to perceive a complex tactile environment. Your fingertips have high density of nerve endings, which is why you can feel fine details. Your back has lower density, which is why you're less sensitive there. The distribution of nerve endings is something you're born with, though the density can change with use. Musicians often have enhanced sensitivity in their fingers due to increased use and the resulting enhancement of neural representations. Your skin's sensory capability is so sophisticated that you can identify objects by touch alone, distinguish subtle textures, and detect tiny vibrations. 86. Your esophagus uses muscular contractions to move food, not gravity. Many people believe that gravity moves food down your esophagus to your stomach, but that's not entirely accurate. Your esophagus uses muscular contractions called peristalsis to move food downward. You can swallow while standing on your head, and food will still travel down to your stomach. The muscles in your esophageal wall contract in a coordinated wave-like motion that propels the food forward. This same wave-like motion happens throughout your entire digestive tract. In your small intestine, peristalsis mixes food with digestive enzymes and moves it along. In your colon, peristalsis moves waste material toward elimination. This muscular movement is coordinated by your nervous system. If something damages the nerves controlling your esophagus, swallowing becomes difficult. Some conditions can impair peristalsis, leading to symptoms like food getting stuck. Your esophageal muscles are also under some conscious control, which is why you can deliberately swallow, but once you initiate a swallow, the muscular contractions take over and complete the process automatically. 87. Your stomach doesn't digest itself, partly because it sleeps periodically. Your stomach doesn't just sit there passively, it's actively mixing food with digestive juices and churning. But here's something interesting. Your stomach has periods of relative rest. Between meals, your stomach goes through cycles of activity and inactivity. These cycles, called the migrating motor complex, occur roughly every 90 minutes when your stomach is empty. During the active phase, your stomach contracts to move any remaining food toward your small intestine. During the resting phase, your stomach relaxes. If you eat frequently throughout the day, your stomach never really gets these rest periods. This continuous activity might contribute to digestive stress. Interestingly, your stomach acid production also cycles. Your body produces more stomach acid in the evening and at night, which is one reason people often experience heartburn when lying down after eating. This timing seems to be related to your circadian rhythm and the anticipation of food intake. 88. Your appendix isn't completely useless. Despite having no obvious function, your appendix is a small tube attached to the beginning of your colon. For decades, scientists thought it was a useless vestigial remnant of evolution. However, recent research suggests it might serve some functions. Your appendix contains lymphoid tissue, which is part of your immune system. It produces and stores immune cells. Some researchers believe your appendix might serve as a reservoir for beneficial gut bacteria. If your gut bacteria are wiped out by illness or antibiotics, bacteria from your appendix might help repopulate your intestines. Additionally, your appendix might play a role in the immune development of your gut. Certain bacteria that live in your appendix might provide protection. While your appendix isn't essential for survival, many people have had theirs removed without obvious long-term problems. It does seem to serve some purpose. It's a good reminder that we don't fully understand all the functions of every organ in your body. 89. Your gallbladder stores bile that helps you digest fat. Your gallbladder is a small, pear-shaped organ that sits under your liver. It stores bile, a greenish fluid produced by your liver. Bile contains salts and pigments that help break down fat. When you eat fatty food, your gallbladder contracts and releases bile into your small intestine. This bile emulsifies fat, breaking it into smaller droplets that are easier for your digestive enzymes to process. Without bile, fat digestion is much less efficient. Some people develop gallstones, which are hard deposits that form in the gallbladder. These can block the flow of bile and cause severe pain. If gallstones become problematic, the gallbladder can be surgically removed. Interestingly, people can live without a gallbladder. Your liver continues producing bile, and it drips continuously into your intestines instead of being stored and released in boluses. This usually works fine for digestion, though some people experience more frequent loose stools after gallbladder removal. 90. Your body produces different types of cholesterol. Some helpful and some harmful cholesterol often gets a bad reputation, but your body actually needs cholesterol. You need it to produce hormones, to create vitamin D, to build cell membranes, and for many other functions. However, not all cholesterol is the same. You have LDL cholesterol, which is often called bad cholesterol because it can deposit in your arteries and contribute to heart disease. You have HDL cholesterol, which is often called good cholesterol because it helps remove LDL cholesterol from your arteries. You also have triglycerides, which are another type of fat in your blood. Your liver produces most of the cholesterol your body needs, though you also get cholesterol from food. The amount of cholesterol in your diet affects your blood cholesterol levels, though genetics play a major role. Some people can eat high cholesterol foods without their blood cholesterol rising much because their genetics predisposes them to process cholesterol differently. 91. Your liver performs over 500 different functions. We mentioned that your liver can regenerate, but that's just one remarkable thing about it. Your liver performs over 500 different functions. It produces bile to help digest fat, it processes nutrients absorbed from your small intestine, it produces proteins necessary for blood clotting and for transporting nutrients, it filters blood, removing toxins and waste products, it produces glucose when your blood glucose is low, it stores vitamins and minerals, it breaks down hormones after they've done their job, it detoxifies alcohol and drugs, it produces immune factors, it helps regulate blood pressure. Your liver is so important that liver failure is a medical emergency. If your liver stops functioning, waste products accumulate in your blood, affecting your brain and other organs. Fortunately, your liver has remarkable resilience and regenerative capacity, which we discussed earlier. Despite performing so many functions, most people never think about their liver unless something goes wrong. 92. Your bile contains waste products, but is also essential for digestion. Your bile isn't just an aid to digestion, it's also a route for your body to excrete waste. Bile contains bilirubin, a waste product from the breakdown of hemoglobin from old red blood cells. It contains cholesterol. It contains other waste products. Your liver filters these waste products from your blood and puts them into bile, which is then stored in your gallbladder or released into your small intestine. The bile salts help emulsify fat so it can be absorbed. The bilirubin and other pigments give bile its characteristic yellow-green color. Interestingly, the color of your stool is partly determined by bile pigments. When your liver isn't working properly or when your bile ducts are blocked, bilirubin backs up into your blood, causing your skin and whites of your eyes to turn yellow, a condition called jaundice. 93. Your small intestine has a lining that renews itself every 3 to 5 days. Your small intestine is lined with epithelial cells that absorb nutrients. These cells are constantly being damaged by the acidic food passing through and by the mechanical churning of digestion. Your small intestine replaces this entire lining every 3 to 5 days. This is one of the fastest cell replacement rates in your body. The cells that line your small intestine sit on a scaffold of tight junctions that keep food particles from passing directly through. If this lining is damaged, as can happen with certain infections or with inflammatory bowel disease, the integrity of these junctions is compromised. This allows food particles and bacteria to leak through, triggering immune responses and symptoms. The rapid renewal of your small intestine lining means that whatever damage occurs is usually repaired quickly, assuming your health is otherwise good. This renewal requires a tremendous amount of energy and nutrients from your body. 94. Your intestines produce their own protective mucus layer. Your small and large intestines produce a thick layer of mucus that protects the underlying tissue from digestive acids and from friction as food material passes through. This mucus is produced by specialized cells called goblet cells. The mucus contains antimicrobial compounds that help protect you from bacteria. Interestingly, this mucus layer also creates an environment where beneficial bacteria can live. Your gut bacteria live within this mucus layer, which provides them protection while also allowing them to interact with your intestinal lining and your immune system. If your mucus layer is damaged or becomes too thin, bacteria can directly contact your intestinal lining, potentially triggering inflammation. Certain foods and compounds have been shown to strengthen the mucus layer, while others can damage it. The health of your mucus layer is now understood to be very important for digestive health and immune function. 95. Your body has more connections between neurons in your gut than in your spinal cord. Your gut contains an enormous network of neurons. so many that scientists often refer to it as your second brain. This network, called the enteric nervous system, contains about 500 million neurons. That's more neurons than in your spinal cord. These neurons control the movements of your digestive tract, regulate the release of digestive enzymes, and monitor the composition of the material passing through your intestines. Your gut neurons also produce neurotransmitters like serotonin and dopamine. In fact, about 95% of your body's serotonin is produced in your gut. These gut-produced neurotransmitters influence your mood and your brain function. There's a bidirectional communication system between your gut and your brain. Your gut bacteria influence your mood and stress response. Your stress and emotions influence your digestion. This gut-brain axis is an area of intense research, as scientists are uncovering how intimately connected your digestive system and your mental health are. 96. You produce different types of white blood cells at different rates, depending on your needs. Your bone marrow doesn't just produce white blood cells at a constant rate, it adjusts production based on what your body needs. When you have a bacterial infection, your bone marrow produces more neutrophils, which are the white blood cells specialized for fighting bacteria. When you have a viral infection, your bone marrow produces more lymphocytes, which include T cells and B cells. If you have an allergic reaction, your bone marrow produces more eosinophils. This adjustment happens through chemical signals called cytokines that your immune system produces. Your bone marrow is essentially a responsive factory that can shift its production based on feedback from your immune system about what threats you're facing. This responsiveness is crucial for your immune system's ability to deal with different types of infections. In some conditions, this responsiveness can go wrong, leading to an overproduction of certain white blood cells, which can contribute to disease. 97. Your bone contains living cells that are constantly rebuilding your bones. Might seem like static structures, but they're actually living tissue that's constantly being rebuilt. Inside your bones are living cells called osteocytes that maintain the bone matrix. Osteoclasts break down old bone. Osteoblasts build new bone. This remodeling is coordinated so that bone is constantly being replaced while maintaining structural strength. The process is influenced by mechanical stress, hormones, and nutritional status. If you exercise regularly and put stress on your bones, they respond by becoming stronger. If you're immobile for extended periods, your bones weaken. This is why astronauts experience significant bone loss in space. The remodeling process requires adequate calcium, vitamin D, and other nutrients. Without these, bone remodeling becomes imbalanced, and you lose more bone than is being replaced. This is what happens in osteoporosis, where bones become porous and fragile. 98. Your fat tissue isn't just a storage organ, it's an endocrine organ. For decades, fat was thought to be metabolically inert tissue whose only purpose was to store energy. But research has revealed that fat tissue is actually an endocrine organ that produces hormones and other signaling molecules. Your fat tissue produces leptin, a hormone that signals to your brain that you're full. It produces adiponectin, which is involved in glucose metabolism and has anti-inflammatory effects. It produces resistin, which affects insulin sensitivity. It produces various other cytokines that influence your immune system. When you have too much fat tissue, the hormonal signals from fat become dysregulated. Fat tissue can become inflamed, producing inflammatory cytokines that contribute to chronic disease. This is one mechanism through which obesity contributes to health problems. Your fat tissue is also metabolically active, burning calories even at rest. The amount of fat tissue you have influences your overall metabolism and your hormonal balance. 99. Your breathing changes automatically in response to carbon dioxide, not primarily in response to oxygen. Most people think your breathing is primarily driven by a need for oxygen, but actually, your body's breathing is primarily regulated by carbon dioxide levels. Your brain monitors the pH of your cerebrospinal fluid, which is influenced by carbon dioxide levels. When carbon dioxide levels rise, pH drops, and your brain signals your respiratory center to increase breathing. Your oxygen levels matter too, but your body is much more sensitive to changes in carbon dioxide. This is why you can hold your breath only so long before the urge to breathe becomes overwhelming. It's not that your oxygen has dropped dangerously low, it's that your carbon dioxide has risen enough to trigger the breathing urge. This sensitivity to carbon dioxide makes evolutionary sense. Carbon dioxide accumulation is a more direct indicator of metabolic activity than oxygen depletion is. By monitoring carbon dioxide, your body ensures that your breathing matches your metabolic demands. 100. Your body keeps precise track of hundreds of different chemical concentrations to maintain homeostasis. Your body maintains homeostasis through an enormous number of regulatory systems. Your kidneys regulate dozens of different electrolyte concentrations. Your liver regulates glucose levels. Your thyroid regulates metabolic rate. Your parathyroid glands regulate calcium levels. Your adrenal glands regulate cortisol and adrenaline. Your pancreas regulates blood glucose and pH. Each of these regulatory systems is working in real time, constantly making small adjustments to maintain balance. Your body monitors oxygen and carbon dioxide concentrations. It monitors pH. It monitors osmolarity, which is the concentration of dissolved particles in your blood. It monitors blood pressure. It monitors blood glucose. It monitors hormone levels. It monitors temperature, and it monitors dozens of other variables. All of this monitoring and adjustment happens automatically, silently, without your conscious awareness. The sophisticated feedback systems maintaining these variables represent millions of years of evolutionary refinement. Your body is capable of maintaining an internal environment that's so stable that your cells can function optimally despite the dramatic changes happening in the world around you. You've now learned 100 things about the body you inhabit. 100 facts that most people never think about. Facts that describe the constant, remarkable process of being alive. Think about what you've absorbed in this time. You've learned about the trillion cells that make up your body, constantly dying and being replaced every moment. You've learned about the systems that protect you and the systems that sustain you. You've learned about your brain, that extraordinary collection of 86 billion neurons generating your thoughts and perceptions and sense of self. You've learned about your immune system, your constant sentinel against the dangers of the world, distinguishing self from non-self moment by moment. You've learned about your hormones, those chemical messengers that regulate everything from your mood to your growth to your response to stress. You've learned about your metabolism, that internal furnace that's constantly working to keep you alive. You've learned about the complexity that exists at scales you can't see, the invisible machinery that keeps you functioning. You've learned about your digestive system, processing every meal into nutrients and energy. You've learned about your circulatory system, delivering oxygen and nutrients to every corner of your body. You've learned about the feedback loops, the regulatory systems, the countless variables that must be kept in balance for you to exist. Most of your life, you're not conscious of any of this. Your body just works. Your heart beats without you thinking about it. Your lungs breathe. Your digestion happens. Your neurons fire in patterns that create your thoughts and feelings. Your immune system protects you. Your bones support you. Your muscles move you through the world. All of this happens automatically, silently, in the background. You are, in a very real sense, a walking miracle of biological engineering. And the remarkable thing is that you can be here, listening to this, absorbing these facts about yourself, while all of this is happening invisibly. You don't have to consciously direct any of it. Your body directs itself. Billions of years of evolution have resulted in this. You contain within you the result of countless adaptations, countless refinements, countless evolutionary experiments. Some things about your body are remnants of our evolutionary past. The blind spot in your eye, the appendix in your abdomen, the wisdom teeth that cause problems. These are evolutionary holdovers that aren't as useful now as they once were. But most of your systems are exquisitely designed for the purposes they serve. As you drift toward sleep tonight, carrying these 100 facts with you, let the complexity and wonder of it all wash over you. You're not just a person. You're a biological system of incomprehensible sophistication. You're a collaboration between your conscious mind and systems working silently in your body at every moment. You're a universe unto yourself, teeming with life and activity. The same forces that move planets and stars are operating inside you right now in the form of chemical reactions and electrical impulses and mechanical processes. You're made of the same atoms that make up the Earth and the stars. You're temporary arrangements of these atoms, arranged in a pattern complex enough to be conscious, complex enough to wonder about your own complexity. You're at the intersection of physics, chemistry, and biology. You're alive, and that life, that aliveness, is happening within you right now, this moment, even as you listen to this. So rest well. Your body will continue its endless work while you sleep, maintaining and repairing and preparing for tomorrow. Your heart will beat, your lungs will breathe, your brain will dream, your immune system will patrol, your cells will renew themselves, everything will continue, a symphony of biological processes orchestrated by systems refined through millions of years of evolution. You are in good hands. You are in the hands of your own extraordinary physiology. Thank you for spending this time with us. Sleep well.